The growth, transfer, and spread GTS of cancer cells in the human body using the Viscoplastopology research model, number 1523, VPT 79, the 4th of February 2026, Gerald C. EclaireMD Foundation. Category: Cancer. Preface: after completing my article No.1523 on the new U.S. dietary guidelines and my own lifestyle journey through metabolic disorders and major mortality diseases such as heart attacks, kidney failure, and stroke, I began to think more deeply about other serious threats, especially dementia and cancer, which I have not been diagnosed with. Cancer concerns me most because it begins at the cellular level, the most fundamental level of the human body. While damage to tissues and organs can sometimes be reversed, cellular damage is often permanent. Over many years, I have studied and written extensively on dementia and cancer from a systems perspective using long-term data. In this article, I focus on how cancer cells grow, transfer, and spread from one organ to another. In academic medicine, these processes are called proliferation and metastasis. However, my intended readers are ordinary people and patients living with metabolic disorders such as obesity, diabetes, hypertension, and abnormal blood lipids, along with related diseases affecting the heart, liver, pancreas, kidneys, nerves, or brain. After 17 years of self-study and more than 1,500 medical research papers, I have deliberately chosen to write in plain language. Plain language does not mean weak science. The methods and logic in my work remain rigorous. These studies are not written for marketing, internet attention, money, or fame. My only purpose is to share what I have learned through long-term observation, large-scale data analysis, and millions of self-collected measurements, so that ordinary people can better understand their own health. Health and longevity are my only goals. Most medical writing is produced by professionals for professionals, which often leaves ordinary people confused or excluded. My work moves in the opposite direction, from institutions to humans, from medical labels to real understanding of how the body works. Introduction: this paper examines the growth, transfer, and spread of cancer cells in the human body using the Viscoplastopology framework. My research typically begins with observed data patterns and biological deviations, then applies math-physical reasoning to understand how multiple long-term stresses interact. In this article, I apply this approach to cancer cell movement between organs using my own longitudinal lifestyle and biomarker data. This is a modeling study for education and understanding, not for diagnosis. It is not medical advice and does not diagnose cancer or determine whether cancer has grown or spread in any individual. Case Study Overview: this case study examines 3 well-recognized pathways of cancer spread: colon to liver, breast to lung, breast to spine. These pathways are common in clinical medicine and clearly how body structure, blood flow, and physical stress interact over time. Study purpose: I do not have tumor images, biopsy results, or pathology confirmation. Therefore, this study does not attempt to diagnose cancer or prove that cancer has spread. Instead, the goal is to evaluate whether my body conditions over time are more or less favorable for cancer cells to grow, enter circulation, move through the body, and settle in other organs. This is a study of environmental permissiveness, not diagnosis. Body connections and barriers: organs are connected by blood flow and fluid pathways, while vessel walls, tissue structure, and immune defense act as natural barriers. Blood from the colon flows directly to the liver, creating a natural path between the two. Blood leaving the breast passes through the lungs, making the lungs a common destination. The breast is also connected to the spine through blood and fluid pathways where flow can be slow or reversed, allowing cancer cells to quietly reach spinal bones when long-term conditions such as high blood sugar, excess weight, and high blood pressure weaken these barriers. It becomes easier for cancer cells to move and spread. Metabolic disorders such as obesity, diabetes, hypertension, abnormal blood lipids, and poor vascular health do not directly create cancer cells, but they strongly shape the internal environment that allows cancer cells to grow, survive, and spread. Genetic factors and environmental pollution also contribute, commonly estimated either at roughly 20% to 35% of cancer risk. While genetics, aging, and pollution cannot be fully controlled, lifestyle-driven metabolic conditions account for an estimated 65% to 80% of cancer risk and are largely within personal control. Physical stress and structural failure: blood pressure repeatedly pushes against vessel walls. High average pressure or frequent pressure spikes increase vessel stress, When vessels become stiff or damaged, it becomes easier for cancer cells to attach, cross vessel walls, and survive. The spine is especially vulnerable because it supports body weight. Everyday activities such as standing, walking, and bending place constant load on it. When cancer weakens spinal bone, even normal movement can cause collapse, nerve compression, paralysis, and severe pain. Cancer spread is therefore not only cell growth, but also weakened structure failing under daily load. Cancer spread permissiveness score MYP. To describe how favorable my body conditions are for cancer growth and spread, I use one score of metastatic transfer, permissiveness MTP. Higher MTP means the body environment is more favorable for cancer cell growth, transfer, and spread. Lower MTP means better conditions. This score is not a diagnosis. MTP is my selected output strain and is calculated as MTP equals 100 *0.2 weight over 170 plus 0.4 FPG 90 plus 0.2 BP M3 plus 0.1 food M9 plus 0.1 exercise M5. My four selected input stressors are visceral fat percentage, VF% daily pressure pulse, PPS LET hours per night, carbs and sugar grams per meal. Long-term cancer risk accumulation. Cancer risk does not arise from a single measurement. It builds over time. Persistent and favorable conditions matter far more than brief changes. Tracking cumulative MTP energy and geometric change using the Viscoplastopology framework reveals when my cancer risk increases, stabilizes, or declines. A quick summarized timeline context: 2010 to 2013, higher weight and glucose, higher carbs and sugar with less exercise, more energy accumulated, and weaker repair. 2014 to 2024, improved metabolic control, healthier vessels, stronger repair from sustained lifestyle changes. 2025 to 2026, possible repair decline after my stroke in June 2025 and possible glucose rise, creating a new turning point. Interpreting the three cancer spread pathways: colon to liver is driven mainly by metabolic stress. Breast to lung is driven mainly by vessel stress. Breast to spine combines weak connections and physical load, making structural failure especially dangerous. The same lifestyle factors act differently, depending on where cancer cells travel. VMT analysis results. First, the cumulative VMT energy contribution ratios are: visceral fat equals 21%, pressure pulse equals 20%, walking steps equals 21%, carbs and sugar equals 39%. Carbohydrates and sugar intake, representing diabetes burden, is the dominant influencing factor. The other three input stressors contribute at nearly equal levels. Second, from the cumulative VMT energy curve, 60% in 2015 and 74% in 2026 mark the pivoting periods. After 2016, cumulative energy remains at a plateau, fluctuating between approximately 75% and 81%. TDA analysis results. TDA shows a clear topological separation between early years 2010 to 2014 and later years 2015-2025. Early data points occupy a wide, high-energy region characterized by high MTP and elevated carbs and sugar intake. After 2014, the point cloud collapses into a compact, low-energy region, indicating a clear shift in system behavior rather than slow incremental change. This compact topology remains stable through 2025, despite aging and post-stroke effects. Carbs and sugar dominate the spatial separation, while visceral fat, pressure pulse, and sleep shape slower, secondary curvature of the trajectory. In summary, TDA confirms that metabolic and cancer-related risk reduction occurred through a phase space collapse driven primarily by sustained control of carbohydrates and sugar intake. Conclusion: both VMT and TDA analyses reach the same conclusion. My long-term cancer risk has been reduced through sustained lifestyle control of obesity and diabetes, tight regulation of carbohydrate and sugar intake, together with lasting reduction in body weight and visceral fat, shifted my metabolic state into a stable low-risk structure. This change is not a rebound or a bounce. It is the result of long-term lifestyle control that has held for more than a decade. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand health, prevent disease, and live longer, healthier lives. This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered or republished as your own. All intellectual This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.